AI, machine learning, deep learning, generative AI. You hear these buzzwords thrown around everywhere, right? But what do they actually mean? And more importantly, how do they all fit together? Well, let's break it all down.
So let me just start by asking you a quick question. Did you use any AI today? And before you say no, I'm willing to bet the answer is a huge, definite yes. Probably way more times than you even realize.
I mean, think about it. If you unlocked your phone with your face, yep, that's AI. If your streaming service recommended a new show that you actually loved, that's AI too. Asked Siri or another assistant about the weather, used Google Maps to dodge that morning traffic jam. You guessed it. That's all AI, working quietly in the background.
So, what even is artificial intelligence? Well, at the highest level, you can think of AI as the big, overarching dream. It's this huge field of science dedicated to building machines that can do things that normally require a human brain. Things like learning, reasoning, or solving problems. Think of AI as the entire universe we're about to explore.
Now, inside that giant universe, the most important galaxy, the one that's really driving almost everything we see today, is machine learning. It is the powerful engine behind pretty much all modern AI.
And this is where a really fundamental shift in thinking happened. For years, we had to program computers with very specific, explicit rules for every single task. Machine learning completely flips that on its head. Instead of us feeding the machine the rules, we feed it a ton of data and let it figure out the rules for itself. Here's the easiest way to picture the difference. With traditional programming, you give the computer your input plus the rules and it spits out an output. But with machine learning, it's totally different. You give it the input and you give it the desired output, and the machine itself writes the rules. It literally learns by example. This learning thing basically happens in a two-step dance. The first part is called training. So imagine a bank feeds an AI model thousands and thousands of old loan applications. It shows the AI which ones were approved and which were denied. The model just chugs through all that data, learning the patterns. The second part is called inference. Now that the model is trained, it can look at a brand new application it's never seen before and use those rules it learned to make a prediction, approve or deny. Okay, so it turns out there isn't just one way for a machine to learn. You can think of it like there are three main teaching strategies that we use. They're called supervised, unsupervised, and reinforcement learning. First up, we have supervised learning. Honestly, the best way to think about this is like studying for a test with flashcards. Where you have the question on the front and the answer on the back? That's exactly it. The machine gets data that's already neatly labeled with the correct answers, so it can easily learn the connections. And this is incredibly useful for all sorts of real-world stuff. Your email inbox, sorting out spam from not spam, that's supervised learning. So is training an AI to detect potential tumors in medical x-rays, or even predicting things like the price of a house or when your pizza's going to show up.
All right, next up is unsupervised learning. Now for this one, imagine I dump a giant messy pile of Legos on the floor in front of you, all different colors, shapes, and sizes, and I just say, sort them. I don't give you any rules. That's unsupervised learning. The machine gets a bunch of unlabeled data and has to find the hidden patterns and groupings all by itself.
This is perfect for trying to find the order in chaos. Things like automatically grouping thousands of news articles by what they're about, or helping companies segment their customers into different marketing groups. It's also huge for cybersecurity, where it can spot weird, unusual activity that might be a threat. And the third method is reinforcement learning, and this one is a lot like training a pet. You have an AI agent that learns by pure trial and error. When it makes a good move, it gets a reward, like a digital treat. When it makes a bad move, it gets a penalty. Over millions of tries, it learns the best strategy to get the most rewards. This is how AI gets so good at playing complex games or even controlling robots. So this all works great for structured data, stuff that fits nicely into spreadsheets. But what about the really messy, complicated stuff that makes up our actual world? How does a machine learn to look at a photograph and actually understand what's in it, or understand the nuances of what I'm saying right now? Well, for that, you need something even more powerful. And this is where we get to deep learning. If machine learning is the engine, you can think of deep learning as the supercharged, high-performance version of that engine. It's a specific type of machine learning that has absolutely revolutionized the entire field. The magic trick behind deep learning is something called neural networks. These are incredibly complex systems with many, many layers that are loosely inspired by the web of neurons in our own brains. And it's this deep, layered structure that lets them learn patterns that are way too complex for other methods. And that's exactly why it's such a game changer.
Deep learning is what finally allows machines to make sense of all that messy, unstructured data. The raw stuff of life. It's the technology that powers facial recognition on your phone, lets smart assistants actually understand your commands, and allows self-driving cars to see and interpret the world around them.
And that powerful engine has brought us to the absolute cutting edge. This is the stuff that has everybody talking right now. We're now moving from AI that just analyzes or predicts to AI that can actually create. Let's talk about generative AI. So what makes generative AI so different? Well, it takes this incredible leap forward. It doesn't just classify an image or predict a number. It learns the underlying patterns of the data so deeply that it can generate brand new, completely original content that looks just like the stuff it was trained on.
And what can it generate? Well, pretty much anything you can think of. New, human-like text from tools like ChatGPT, stunning, photorealistic images from Midjourney, and now even entire video clips from models like Sora. It can even write working computer code for you like GitHub Copilot. It's not just an analyst anymore, it's a creator.
Okay, wow, we have covered a lot of ground. So let's just take a second, zoom all the way back out, and put all these pieces together so we can see that big picture nice and clearly.
The easiest way to think about it is like a set of Russian nesting dolls. The biggest doll on the outside is artificial intelligence. That's the whole field, the big dream. You open it up and inside you have machine learning. That's the main method we're using to achieve AI. And then you open that up and you find the powerful core, deep learning, the engine that uses neural networks to drive all the most advanced breakthroughs.
So, the main thing to walk away with is this. When you hear people talking about AI in the news today, they are almost always talking about machine learning. And when you see those incredible, mind-blowing new things that AI can do, you can be pretty darn sure that deep learning is the powerhouse behind it all.
We've gone from simply unlocking a phone to generating an entire video from just a sentence. The pace of change here is just staggering. And it leaves us with this one giant final question. Now that AI can learn, analyze, and create, what in the world comes next?